For this problem, we have the function y equals 1 over x minus 2. We're going to find the critical values for this function. And since when we find the critical value, we're going to start with finding the derivative, which is the y prime. And then we're going to look at two cases, y prime equals 0 or the y prime is undefined or doesn't exist. Okay, get started with the y prime as y equals 1 over x minus 2. You can treat it by using the quotient rule or write it as the power form. So let's work on the power form. So y equals 1 over x minus 2 is the same as x minus 2 to the negative first power. When I write in this way, I'm going to use the general power rule to find y prime. So my y prime, if you recall the general power rule, I'm going to put a note here, which is from y equals the quantity gx to the power n. So the y prime is n times the gx to the power n minus 1 multiplied by the g prime of the x. Okay, so that means, let me write it one more time here, so g prime at the x. So we're gonna need the n, the g, and the g prime. For our case, the n is -1. The gx is x minus 2. That means our g prime gonna be 1. Okay, and bring everything back into the formula using the general power rule. The n is -1. The quantity gx is the quantity x minus 2. The power -1 minus 1 and multiply by the derivative the g, which is 1, and simplify it to be negative of the quantity x minus 2 to the power -2. Or you can write y prime as -1 over the quantity x minus 2 to the power 2. All right, we have the y prime in the fraction form. And then from this form, let's see. Oh, one more thing that we did not put a note on the side. From the function that we have, this is the rational function. So I'm going to put a note. This is the rational. For the rational function, the restriction is the denominator cannot be 0. So x minus 2 cannot be 0. That means x cannot be 2. Or the function will not be defined at x equals 2. Okay, put a note there. So that's the domain of the function or the restriction of this function. So since we find the y prime in the form of -1 over x minus 2 quantity power 2, to find the critical number, we're gonna look at two different cases. For the case that y prime equals 0, and for the case that y prime is undefined. Okay, two cases. When you're going to consider both cases or just one of those two, when you have y prime in the fraction form, the numerator divided by denominator. The case that y prime is 0 is a case that the numerator equals 0. The denominator is 0 is a case of the undefined. You have the y prime in a fraction form. So the numerator for this case is -1. Is -1 equals 0? No, it's not. So then no critical value from the case of the y prime equals 0. Another part, we consider denominator equals 0, which is the quantity x minus 2 squared equals 0. To solve for x, yes, we're going to get x equals 2. Looks like we get the winner, or x equals 2. But in fact, the function y equals 1 over x minus 2 is not defined at x equals 2, even though we find the answer, but we cannot take it because 2 is not part of the domain. So then in this case, we do not have critical value. What does it mean? It means the graph will not give you the local max, local min for this case. And if you plot the graph, I'm going to plot the graph, show you real quick how the graph works. Okay, use the graphing calculator. I'm going to clear the screen. So put the y, the function is 1 divided by the quantity x minus 2. And then we're going to graph it. And the graph will be like, there are two pieces. And x equals 2 is the vertical asymptote. The graph is falling down all the way. The graph is also falling down all the way on the right hand side. But these two graphs do not meet each other because the vertical asymptote, they separate them apart. Okay. And when we come back here, if you draw the real number line, the value 2, you can locate it on the line, but you cannot use it as the actual value that you're going to find the function value. The left hand side, since the y prime is in the form of negative 1 over x minus 2 quantity squared, the power to always give you positive. It doesn't matter what the quantity inside before you raise to the power 2. Then the negative side here will confirm that whatever the number that you plug in, the final number gonna be negative inside. So negative here. The graph decreasing both sides of the x equals 2. So that's why you see the graph on the calculator that at x equals 2, that is the vertical asymptote, and the graph gonna be coming down and also coming down. So no critical values for this problem.